Good evening, everyone. Hope all of you had an amazing day so far. Welcome to the first live stream of Nerds Nerd Alpha on C++. Before I proceed further, just a few words about NUA, our community. So it's all about, we promote the educational and entertainment perspective of GPUs, graphics processing units. So our motive in three words is basically AI, GPU, and gaming. So do check out other videos in our channel. We have made videos on Jetson as well. Do check them out. So today we'll be mainly concentrating on C++, which is required in high performance computing and also in the embedded industry. So with us, we have our speakers, Suhan Roy and Abhigyan Karmakar. So hi guys, how are you doing?
Hi, I'm doing fine. This has been a great experience. So
Okay. That's really great. So, how has been the lockdown holding you up?
the lockdown has been actually pretty rough, considering my situation, which gives me very poor internet access. So I'm creative with books and stuff to learn new things. But that has given me a lot of time to work on my hobbies, so that's fun.
Yeah, definitely. That's. I mean, in some ways, the lockdown has brought out some positivity in us. Like, yeah, we are trying to be creative, how to make the best use of our time. Definitely. So, Suhan, how are you?
Yeah, hello everyone. So I'm great, guys. So as he said, as Abhigyan already mentioned, like we have this lockdown period going on, and we have been stuck at home lately, doing our own stuff and all that. But it's good to have a time like this that we can, do some self-reflection, utilize this time for some, productive work, and then we can join.
That's yeah, definitely. Like I agree with you. So Avigyan, just tell a little bit about yourself, like what you are doing right now, and what are we going to discuss about today, just in brief.
I'm Abhigyan Karmakar to begin with. I am a third year college student from Heritage Institute of Technology in Kolkata. And today we are going to talk about a bit about smart pointers and templates and template metaprogramming in C++. Basically, the modern styles of writing that moves away from the archaic C style coding that we all used to nowadays.
Okay, okay. That's great then. So personally, like I'm also looking forward to learn from you. And Suhan, what are we expecting from you today? But yeah, just tell us a bit about yourself also.
Like I'm currently a final year student, and I mainly do projects on Python and C++ related to machine learning, all that stuff. I'm a like huge machine learning enthusiast, if you can say it. So basically, what I want to speak about today basically is that how we can use the power of C++ in various fields, like in machine learning, in game development, and all the related stuff. Like how we can use these useful features that C++ has, how to leverage them, and why should
That
we learn, and why should we like look forward to learning more about C++ in the coming days.
That's really awesome, and I guess the audience, the spectators, will be really looking forward to learn those stuff. Definitely. So, since guys, Avigyan is kind of having some internet issues, so what we have done is like we have a pre-recorded session of whatever he was going to present today. So, Nova, aka Sora Rudra, can we have that?
So, we begin today's session with smart pointers. What are smart pointers? Smart pointers are nothing but wrapper classes around raw pointers. Now, you might wonder what makes these pointers smart. Well, they have scope based memory management. To understand what that means, let us now first look at the workflow of normal heap memory allocation, that is, dynamic memory allocation, using the new operator, and then we move on from there. As our first example, we here have a dummy class that has an instance created writing constructor, and instance destroyed writing destructor, just so for clarity onto the console screen. And then below that we have just a normal wrapper function that allocates memory to a pointer PTR using the new operator of type dummy class. As you can see here, the size above is written as 1. This was done purely for reasons as to keep the console clean, because you don't want to have thousands of instances created being written onto the console while understanding concepts. But you can change the size as you want. I'll give this code down in the link below too, so you can check it out if you want. Even now you can code along if you want to. So here, as you can see, the workflow includes us assigning a pointer to the newly created memory chunk by the operator new, and then doing stuff with it. And then after we are done with this pointer, we delete it using the delete operator. Pretty simple stuff. Now, what happens if the delete part gets skipped? Or let's say you just straight up forget to write the delete part. Or let's say then an exception or some other thing breaks the flow of your program and does not call the delete function. Then what you have is a memory leak. And memory leaks can be a very, very dangerous thing, especially when you're working in constrained memory environments. So, as a way to go past this problem, we have std unique pointer, which is the first of our smart pointers. Now let us have a look at what std unique pointer does. Let's say instead of this pointer pointing directly to the new memory block, we wrap a std smart pointer around this. What will happen is, even if we do not call the delete function, or the delete operator actually, even if we do not call the delete operator, once the PTR pointer goes out of scope, it will be deleted automatically. That is, that when PTR goes out of scope, the smart pointer wrapper will call the associated deleter, that is here the destructor for dummy class, onto the new memory block and free that memory for other use automatically without any manual intervention. So let us have a look at how that happens at first. So first we begin by running this code that allocates and deallocates memory. Here, let's go down to main. We use the foo function that we used, and we are expecting to see an instance being created and destroyed here. As you can see, it writes instance created and instance destroyed because we allocated one sized array to it and it's creating only just one, and then when it's done, it's destroying it. Now let's remove this delete line, and after we remove the delete line and we run it again, we expect to see only instance created, and here you go. You have only instance created written onto the screen because the delete part got skipped, and hence you have a memory leak here. Now, instead of this here, I'll just go down and use unique pointer. Now let's not think about the commented out line first. Let's look at this. Instead of using the new directly, I'm wrapping it around a unique pointer here. Let me change this to size, and yeah. So since I'm wrapping this inside unique pointer and then operating it here, this ARR is essentially a unique pointer, smart pointer that is pointing to the memory block dummy class size that was assigned to it by the new operator. Now, as you can see, there is no delete function being called here, and there is a mark that says that we are quitting the function here. Now, what will happen if we run this program? Now, you might think that not using delete might cause it to write only instance created, right? That's what we are expecting. But when I run this program, you can see that here an instance is created, but after quitting the function, although we did not do anything, the instance is automatically destroyed. Now, why does this happen? Like I said before, smart pointers have scope-based memory management. So when the PTR pointer, or in this case, the ARR pointer, when it went out of scope from this using PTR function, it called delete onto the memory block automatically, because since it was out of scope, there was no pointer pointing to that memory block, so it was useless now. So that is what makes smart pointer smart. Now, this was only one out of the 3 smart pointers that C++ allows us to use. Let us now have a look at the second one. Now, to understand the usage of the second smart pointer after unique pointer, we first need to understand one very important characteristic of unique pointer. Unique pointer guarantees that there will be only one pointer pointing to the memory allocated to it. For example, with normal pointers, if you have a memory block M, you can point n number of pointers towards it, pointer 1, pointer 2, so on and so forth. But with unique pointer, if you try to assign another pointer to the same memory block, you'll get an error, as I'll show you here. Let's say I write auto ARR2 and then try to assign it to the first pointer, that is essentially the memory block that it points to. You'll see that it gets a red underline. And if you highlight this into the console errors, you'll see that it says that it cannot do this because it's a deleted function. And it says that because essentially a unique pointer does not let anything else point to it, hence making it unique. So if you try this, it'll just say that this function does not exist at all, so as to prevent you from doing stuff that will be out of the standard. So to get around this, let's say you have a program that needs 2 pointers or 3 pointers or n number of pointers pointing to one memory location, which is very common if you do parallel programming or work with multiple other accesses to the same memory block or what have you. So for that, we have std shared pointer that lets you point n number of pointers towards the same memory block, and it still does the same function. It has the same functionality as unique pointer, that is, when it goes out of scope, it deletes the memory automatically. Just the method is slightly different. For every pointer, I'll just go down here and let's not look at the code now. For every pointer that is newly allocated to that memory block, the make shared keeps a reference counter that goes up by 1 when you assign a new pointer to that memory block, and when you unassign it, that is, let's say a pointer goes out of scope, then it decreases the reference counter by 1. Now the shared pointer calls delete on the variable or the memory block it is pointing to when the reference counter reaches 0. I'll show that to you here. For example, let's say I have a shared pointer here that is allocating an array of size 1, as we showed here before. Size is 1, and we are using this. Now notice I'm using a make shared that is actually done for exception safety. Actually, we'll go back here. Let's look at this. Instead of using std unique pointer like I did below, we should actually use the make unique function and then give it the operator type and then give it the size. This will be exception safe, and it also mitigates one argument evaluation problem that was prevalent until C++14, but it was removed in C++17, so I'm not getting into that. But if you want to check it out, you can Google it. Below that, so we have the make unique function that basically just does this line that I commented out here, but it makes it safer by wrapping it around a function. Similarly, for make shared, we have the for shared pointer, basically we have the make shared function. Also, unlike unique pointer, make shared has one more caveat. The shared pointer variable, it keeps more data than it actually assigns. Like, for example, what I mean by that is, since I am allocating size memory here, so it's basically size of dummy class into size, right? But the actual required space for this shared pointer is more than that. So if I directly write shared pointer instead of using make shared, what will actually happen is the new memory will be allocated, and then again another chunk of memory will be allocated that will be the size of the required pointer and the new memory, and the previously allocated new memory will be copied. So it will work, but it will be very inefficient. So we use the make shared function here. Now, as you can see, I am assigning a pointer to this class here, and I'm making it a shared pointer. Now if I use this here, and let's cut the unique pointer function out, and let's say I'm using the shared pointer, sorry. I'll use this, I'll run it, and the behavior is similar to what we've seen before. Its instances were created, the function was quit, and the instance was destroyed. Now, to show you the part of the shared pointer that makes it shared, for example, we have a shared pointer global variable here, and we have a shared pointer, another one here. You see, I'm pointing to this memory location essentially via this, but it does not give me a red underline like the previous unique pointer. This is because I get to put multiple pointers to the same location here. I'll do this with this too to show you the reference counting part. Let's say using shared pointer, I'll just write a function here. Output, let's say main ends. Write this, and let's see what happens now. Now you see an instance was created. We quit the function, but we have not still deleted it. We have not called delete like the previous versions. This is because the global variable that we assign that memory block to is still alive even though we exited the function. So now we see here main ends, and then the instance is destroyed because now the global variable that pointed to that memory block is dead too. So that is all about shared pointers. And now we move on to the final one, that is std weak pointer. Now before we look at this code, let me ask you a question. Let's say you keep a list of the shared pointers. Now every shared pointer is guaranteeing that whenever you use that variable, like every shared pointer variable, it guarantees that while that variable itself is alive, the memory block will be alive. Now what if you needed to keep a list of, let's say, the elements, but you don't need to necessarily keep the elements alive? Let's say you have a list of bulbs, right, that you're keeping for a checklist. Now for that checklist, you don't need to ensure that every bulb on your list is always alive. You can just make sure that when you check for the bulb, you can just check that whether if it's alive. Let's say bulb number 13, is it alive or is it dead? Similarly, for users like that, where let's say you just need a list of the elements, you don't care if they're alive, you can access it or not, you just need to know if it was there or if it is there, right? For that, we have std weak pointer. std weak pointer is sort of like an accessor for shared pointers that basically what it does is it gives you access to the shared pointers memory block, but it does not ensure that it will be alive. For example, I'll just show you here. It says auto array new style. We'll just use that name here, and I'm creating a shared pointer similar to here. And here I'm using the archaic method instead of make unique. Actually, I'll just copy this here to use this. Much better. So that should be much better now, actually. Okay, then we have this array new style, and we have this weak pointer. This is a global weak pointer, by the way, so that I can show you the lifetime thing. So if this was a shared pointer, what would we expect? That main would end, and then and only then the function would call delete onto the memory block, right? But here, since this is a weak pointer, the moment we exit using weak ptr, the delete function will be called. For example, I'll show you here. Here, the weak pointer's name was weak pointer array weak. Now is array weak. Now weak pointers have this nifty little function called expired that tells you whether something is expired. I'll show this to you here too. Let's go. Now this function returns 1 if the element has expired and 0 if it has not expired. It returns a boolean flag basically. So what we're expecting to see is this pointer here gets allocated, so we get an instance created. We get the bool status of expired no, or 0 because, well, it's alive because it's still in the scope. Then we quit the function, then the instance is destroyed, and then we get a main ends. Actually, I'll put it above main ends to give it more clarity. So then we get another array expired flag, but this time it will say that it should have died because here this thing killed the memory block, but the weak pointer is still pointing to it because that is allowed now. So let's say weak status main. And let's see what happens if we run this. And you can see that instances were created. The function was quit. Weak status of main is currently 1 because it has expired. Main ends, instance is destroyed. Oh, I'm sorry. I used the wrong function here. That's why I was wondering it was showing something weird. My bad. Let's go with the using weak pointer. I wondered why that was going weird. Anyway, this should show the correct one actually now. Let's go here. Sorry about that previous shindig. Here you can see instance created, bool status expired. No, it's quit. The instance is destroyed the moment this function is quit. I'm inside main. The weak status is 1. That means the expired status is 1. That means it's expired because, well, here we kill the destroyed. And then main ends as usual. So these were the 3 smart pointers. Now there are a lot of uses of smart pointers that I cannot go into with depth because of the short time we've been allocated here. But in the links below, in the description, you can see there will be a GitHub link where I'll be posting some code and some extra links and stuff you can study up on for this and the next upcoming talk on templates. So with this, let's move on from smart pointers onto templates. Now that we are done with smart pointers, let's get started with templates. Templates, as we know, are C++'s way of handling generic types. They are generally split into 2 categories, function templates and class templates. Now, templates have been a part of C++ for a long time now. So we'll just have a look at the basic syntax that we all know and then move over to the cooler, newer, brand new stuff. So let's get started. First, we have a look at the most basic usage of generic and template classes. Here we have a function that needs to add 2 variables and needs to work for all 4 data types that are commonly used: int, float, double, and short. So to do so via non-templates would be to overload the function and keep copy pasting it for different data types. Now as you can see that this gets very inefficient and takes up a lot of wastage. Now we have the template version of it, add overload template below it, that uses the template type t to return var1 plus var2 of the template type t that we get by calling it with the appropriate class function. A class of the function. Let's say you want the integer class or float class or double class or short class. Then we have another syntactical type of writing the function. It does the same thing but has just a different way of writing it, that is using the trailing return type that uses an auto return type, and then calculates the return type by using the decl type that returns the basically the usages of that a plus b expressions data type. This is all very normal and has been around for almost over 2 decades, I think, at this point. Then we move on to class templates. Here we have a simple dummy class with a dummy variable that is of type t, and we can write template type name t, and then we write the vector class that we need here around this container class that is dummy template class. Below are the constructors. This is just some syntactical revision, nothing more. We have all seen this before. What is new though, you might notice about this, is that I wrote type name t equal to float. This is a default argument allowed for type names nowadays. So I'm using a default argument here. This was introduced in C++17. So now we can use default arguments for templates too, which makes some debugging easier to do, especially when you're working with methods that work with multiple substitutions that could be possibly done, and some of them not working for all instances. So now that we're done with basic templates, we move on to the slightly newer stuff. First, we begin with C++11's. Although a decade old, it's still a little fresh and it's nice to use. We have Variatic templates that made the usage of VA lists and VA start, then iterating over through that, then VA ending, basically the whole concept of VA lists from C redundant. As we can see here, as written below, let's say you need to variadically add 10 or 20 or any n number of arguments. How we would do this is, first, let's say you create the function first. there will be only three categories of the arguments as given by the old template system. There will be either one argument, there will be either two arguments, or there will be over two arguments. For one argument, we just return the variadic add TA, that is the input, and we just return A. Then you can see that there is a two variable version, variadic add TA and TB, and we just return A plus B. And for arguments more than two, we have TA, TB, and args, args, that is actually an expression pack as we call it. And not expression pack exactly, it's just an argument pack, sorry. Then we just return A plus B, that is the first two variables of the pack, and then the rest of the pack is recursively called. And when the function is generated via the compiler's directives at runtime, then this recursion is broken down into a normal linear call, and no actual recursion although happens. This is a sort of recursive way of looking at the addition function, and this is nothing that cutting edge too, but it's very cool to use nonetheless. Now we'll have a look at the more modern use of this, that is by using fold expressions that were introduced in C++ 17. So now first we have a look at the most basic of fold expressions. Here you can see that instead of writing all this complicated recursive code, I just have one line of program that says type name ... args, that is the template type. I have an auto returning function that takes in just arguments, a pack of arguments ... args, that is written here, and it returns args plus this triple dot here. What this expression is basically a fold expression that says that I want to unpack this folded operator recursively, and this does it automatically. Here args plus ... here signifies that we need to keep unpacking this from left to right. Let's say you have an argument of, let's say, 1 2 3 4 5 6 7 8 9 10. So this will keep unpacking this ... that signifies the runtime input of 1 to 10 by first going through 1, then plus 2, then plus 3. It is always guaranteed to be left to right. So this is a much cleaner way of looking at templates. As you can clearly see, it's just a one-liner instead of writing three different functions, and it makes life much easier. We can even do other cool stuff with it, like for example this function that calculates averages. We just add up the arguments here like the previous function, and then we have this operator, a newer version of the size of operator that can be used to calculate the size of args. This size of ... operator will calculate how many arguments are given. So no matter what data type, let's say you given an argument of 1, a character C, and the string name. Even though these three are three different types, the arguments list will just return the size of S3 because there are three different arguments into the arg list. So this was fold expressions. This is just a very on the surface explanation of fold expressions. Fold expressions are a very new and complex new feature added. Fold expressions are actually basically just the usage of binary operators on argument packs. I'll be linking a document down below that you can read up on if you want to further study this. Then we move on to one of the more explicit versions of template metaprogramming, that is, here we calculate the factorial. Now I want to preface this by saying that templates are essentially Turing complete inside C++ itself. Templates inside C++, just the templates themselves, are Turing complete. And this is just one part to show that they are. This is a template function that calculates a factorial simply by using templates. This technically does not exist, and this is a runtime metaprogram that generates the code at runtime and then calculates the factorial recursively. As you can see here, first we have a factorial that the factorial will either call up to n, 1 to n, or it will have a 0. For 0, the factorial is always 1, as we know, and for anything n minus 1, not n minus 1, actually 1 to n, everything will be n into n minus 1 into n minus 2 into n minus 3, so on and so forth, as we know the factorial formula. And you can see that a simple way of doing it by template metaprogramming would be this. There's a very cool book. I'll link the name down below for that too. You can read that if you want, that uses template metaprogramming. Uh, Template metaprogramming is actually a very, very large topic that obviously I cannot expand over this short topic, this short speech, but I can still guide you towards what to read up, and the link down below will help you with that. So this was templates. Now we'll look at some of the newer, more cooler versions. First of all, C++ 17 and 20 let us use templates with lambda functions, as you can see here. For example, here I have this lambda function that just outputs the members of a vector. Now, for example, I set up my environment like this. So my release version here, as you can see, is C++ 20, at least the newest version that MSVC supplies. And my debug version is C++ 14, I think. So when I use debug, you'll see that this part gets highlighted. Here you go. A lot of highlighting is being done. That is because this was introduced in C++ 17 and we did not have this before. So this makes the rules, not exactly rules, the way of using lambdas much easier and cleaner, because now you don't have to keep emulating types or working around this. If you need a template type, you can just write it. And then above that, we have something very cool that was introduced in C++ 17 along with fold expressions, is the sitadd rules, or the rules that let you govern how the parameters that are supplied at runtime are checked and can be implicitly used to create arguments for the template class themselves. For example, before, if you've used std vector, you need to write std vector, and then within the angle brackets or chevrons, you need to write the data type explicitly. Now, with sitadd rules, as shown below, you can just write std vector and just write the data types with the initializer list, and it'll deduce the types themselves. Hence the name sitadd, which is class template argument deduction, which is exactly what it does, as I showed you here. And there are some other examples. For example, std tuple, we are just writing it here, which turns C++ less hardly typed than we've been used to. Like, C++ is a statically strong type language, unlike let's say if you've used Python, which is a dynamically typed language. Now here just the std tuple part is there. Before, we used to have to write std tuple, then int, and as the data types get more complex, it keeps getting uglier and uglier, and it makes the code look very convoluted, especially to beginners, or even if you're even if you're experienced and you're staring at a 1,000-line program, it strains your eyes a lot. So this makes stuff look a lot more natural. And with that, we are done here. These were some of the examples of how we call the function, the initial variadic functions of sum that we described above here. This one, I'll show you some examples of the factorial function that we showed here, the average function and the sum function. Let's have a look-see. I'm sorry, there may have been some error. Let's just remove this. We don't need this. Okay, let's go. I realized there was a stray bracket there causing the problem. This one here. So now that that is corrected, we can just run this program and it should run. And here you can see with this console, it's outputting 10. For that was the sum for 1, 2, 3, 4. It's showing you the average that we were using 1, 2, 3, 4, 5, 6, and it's showing the factorial of 15. Factorial 15 as we called it here. As you can see, we're using factorial 15. We're using the average of the first 10 numbers and the sum 1, 2, 3, 4. Just to have a look again, it sums it up to 10. It has an average of 5 and factorial. And these are just some of the light introduction to CTAD rules, fold expressions, and general template usage. Now, if you have any questions, you can ask away. And the links down below, I've already suggested some papers that show you how the language itself, the metaprogramming part of C++ templates is actually Turing complete, and you can have a look at some of the good template libraries if you do want to explore developing with templates. Like Boost has a very good library, the TML, or the template metaprogramming library. A lot of good stuff comes from Boost, I must admit. Like a lot of stuff they introduce and then we just copy it into the C++ standard. Like for example, in C++20 they are getting std format. That was from the formatting library that also was inspired from other external libraries. So a lot of stuff comes through those channels too. So anyway, if you have any questions, you can ask away.
Okay, that was a really very enlightening session. So, a lot on templates, metaprogramming. So, like I personally learned a lot from you, Abhigyan. Really, thank you there. So, Abhigyan, can you hear me?
Yeah, I can hear you.
Yeah. Thank you for this session, man. It was really good. So regarding the questions, we have a separate Q&A session after Suhan's part. So people, you can so guys, you can drop your questions now. So he will respond to them later. We'll respond to them later. So anyways, I think we should start with Suhan. Hey, hi Suhan. Suhan, are you there?
Hello.
Yes, Suhan.
I'm audible, right?
Yeah, crystal clear. You're audible.
All right. So thanks for the session, Abhigyan. Like it was very informative. Lot of. So I think I should start, right, Omlan?
Yeah, I guess like you will be presenting your screen, right?
Yeah, sure.
Okay. Okay, that's so we'll get to see something in real time, hands on.
Yeah. So my session will be a hands-on session, basically, so that everyone will be benefited here. Audience can look at some. Like, please, like respond. Like, if anything is visible or not. I hope everything is visible.
Yeah, it's visible to me.
Please check.
Yes, I see your ID.
All right, fine. So, like I said, that this will be basically a hands-on session, so that the beginners or anyone who wants to get a refresher or something, they can like see the code live and they can get some experience like how to deal with the code beforehand, and they can write programs in STL, and they can get familiar with the syntax. So let's start then. So my topic today is the standard template library in C++ called STL. Now, why is this important? Why do we need STL? The big question. So STL is basically
Yeah.
built-in template library.
Swan,
Hello.
just type that. Make a comment there. Hashtag why it's important. STL.
Yeah, sure. Yeah, sure. So today we are going to learn C plus STL. So This is a $1 million question here, at least, if not
Yep.
million, is quite an important question, I believe. So why do we need STL? STL is basically a built-in library in C++ that allows us to leverage very the very powerful, robust new features of the latest versions of C++. So they have STL has this built-in library, and they have like a variety of like features which beginners can use. Not only beginners, even experienced guys, developers, they can also leverage the use of various containers, algorithms, which can make their lives easier. So, and the best thing about this is that this library is that everything is optimized to the fullest. The one does not need to worry about any time complexity or anything about, say, like space complexity, or whether it will cause problems in a production environment. Nothing to worry about that. So everything's optimized. Everything is the best version of everything. So you need not worry about that. So what is STL basically? STL is a large and complex library, and to be honest, it is very difficult to like discuss like all of the features that is included here. But this session mainly will familiarize everyone, the audience, with the basic features and everything, so that they can get started. So like I said, using STL, we can also save a lot of time and effort, and which can lead to very high quality programs, which is one of the biggest benefit of this library. Now the second question: why C++? So why C++? Like C++ is like I think everyone knows that C is the fastest language in this era, and if there's any language which comes a close second, it's definitely C++. It is very robust. It has a lot of power which we can use in production environments to leverage the best qualities. Like nowadays we have lots of languages available, like Python. We have other languages like Go and all that, but C++ is still the preferred choice of the industrialists or the people working in the industry for production time. And one of the more fundamental reasons is that C++ is a very important core programming language which can be used very effectively in the backend. So because most of the production softwares require lots of high-end performance computations, high-end computing power and a lot of raw power, and C++ can provide that. And because C++ has a lot of other utilities such as STL and all that thing, so it like edges out C in that respect. And because one more factor why we should learn C++. So like C and C++ are very similar to each other. The syntax is very similar, and in fact, like if when we are developing, if we look at it from a developer perspective of view, we can often use C++ and C code interchangeably. Like we know C is faster than C++. So what it gives us that if we want to leverage the best power of the best computing resources we have, so what we can do is that in our environment we can leverage the power of C, right? So the reason this happens is because these two are very similar. These two are very similar, like in terms of syntax, in terms of the paradigms and all that things. So as a result, so this is the end result here. So that's why we need to learn C++ and why we are going to learn more about STL. So I hope everything's clear with that. All right. So now I'm going to discuss a bit about STL and what does STL contain. So the standard template library has 3 basic components. They are containers, algorithms, like all the base algorithms, like binary search, chain heap, and sort, binary sort. So I'm sorry, binary search, linear search, merge sort, everything is available, and we can just import the functions, and then we can use these algorithms in the best time complexity available. And the third is iterators. So these are the three components of C++ STL, and today we are going to look at containers, how we can use the power of containers in C++ STL, and how we can write programs. And then I'm going to, and at the end I will discuss a bit about why we are looking at this, because like how we can use the properties of STL in various other high-end libraries like like NumPy or pandas in machine learning, or say various tensors, vectors, and all these computing libraries and all these computing functions and classes which are highly used in game development purpose, or in deep learning again. And so I hope this will be a very informative session. So let's start. So we are going to start with containers. So what are containers? Containers are basically data structures or objects that can hold data of the same type, right? So if we have an integer container, the container can hold data of integer type. If it is a character container, it can hold data of character type, and so on. So what are we going to look at today? So let's have a quick. So today we are going to look at vectors. These are all containers, all right? Sets. I will discuss everything regarding to like the syntax and how we can use the various functions associated with them, and also their time complexities. And then we are going to discuss so what is that? What is associative or derived containers? So these are our primary containers which are available. Some examples of and what this means is that we can use containers like vectors or sets or pairs. Like I will also mention that set is also a, like you can say, associative container, and so is multimap and map. So these three, map, multimap, and sets, they fall in this category because they can be derived, like derived data types we have. So they can be derived from vectors, or say lists. So these are the vectors, lists, and these are the, you can say, the sequence containers like arrays, and these are the basic containers we have in STL. And then we can derive sets, pairs, maps from vectors and lists. So we are not going to discuss about that, but what we are going to discuss about is how we can use all of them and how we can write programs. And let's start with the code here. All right, so first we're going to look at vectors. So before that, we need to include everything. I hope the code is audible, right? Like the code is visible and my voice is all right, okay?
Yes.
And I hope everything
is
clearly. Yes, all right.
Yep.
Let's start. Let's look at vectors. What are vectors? Vectors are, like you can say, like arrays, very similar to arrays, but they are dynamic in nature, not static like arrays and all that. So what we can have is that the vectors, like we can initialize a vector with some values, or we can leave it as null, and later in the program we can also change the size of the vector. So it is dynamic in nature. We can shrink the vector, we can expand the vector according to our whatever we want to do. And that's not possible in arrays, because arrays are static data types or data structures. So let's look at vector. So what I've done here is that I've declared a vector. So I've initialized a vector A, and it is of type int. So we can store values of type int. It's very similar to a list or an array, and we have stored these here. And similar to in arrays, we can also, get the values like this. So let's find out. So similar to very basic properties of arrays we are using here. So we can find out the values like this, and we can print them. We can print them like this, and this way we can, like this we can print all the, similarly we can print all the values in a vector. Now suppose I want to,
I have one question.
values.
I have one question.
Yeah.
Yeah. So analogous to which data type in Python you can compare vector to?
No, this is not exactly the question of analogous here. See, we can there are lots of containers in C++, and each have their own properties. Yeah, so basically vector, if you want to look at it, it is dynamic, so it is very analogous to list in that perspective, but it also has a few properties which I don't think lists have. So it's not exactly associative or some analogous, something like that. If we want to learn more about vectors, so we can find many
Okay.
unique characteristics, and we can use them as we want. We can write software and use the.
Okay.
So now we want to sort this vector. So let's do that. For that, first we have to include. We have to sort this vector. So we have to include algorithm, which contains this sort function. Otherwise, we cannot use this functionality. So suppose we want to sort this vector. Let's do that. So what I'm doing is, so from beginning to the end, I want to sort this vector. So, like suppose we were not using STL, like what would we do, right? We would try to, we would use merge sort, or we would use quick sort, we had to write the whole algorithm, but due to STL, we do not have to write everything. It can be done automatically. It's done.
So
and
I have one more question here.
Yeah.
I have one more question here. So like this is a predefined algorithm, right? I mean, not algorithm, function. So how is the computational speed here? It is good enough?
I just mentioned here. Yeah, it's quite good. See, it is we are using so the best the best time complexity that there exists for sorting, which is n log n, right? So like I said,
Yeah.
functions and everything, all the functionalities have been optimized to the maximum, so that users can just get
That's
their code.
This is very much like really user friendly here. In fact, very industrial friendly.
Yeah, it's user friendly, it's industry friendly, it's production friendly. That's why it's a choice. Like,
Yep.
there has to be advantages, so that the production minded people can find them very useful. So these are very important to them, right? You cannot worry about the small things, and like want to work on production ready software, isn't it? So next functionality, we'll look at how we can insert values to vector. So let's do that. So what we can do is, we can use a function called a.pushback. Suppose I do 9. So what this does is that it pushes the value 9 to the end of the vector here. So what happens is, we get this. So we get 11 to 14, 13, 9. So very simple. So we just insert values like this.
What if I want to insert value in a particular index? the same way like you printed the output, right? A of 1 is that much. So like how can we do that? I want to insert a value in between the vector
So
indices.
what you can do is that you can simply use another function. So if you want to do that, actually the thing is, Amlan, that this container vector, this is only used for the purpose of keeping actually the sorted way. So what you are telling is that there are other containers available which we can use to keep values in specific positions, which I'm going to discuss later. So the functionality of vectors is like that we can definitely do that, but I will come to your question in a later part. I'll show another
Yeah,
container.
okay, fine.
We can do it even better. So let's go ahead.
Okay.
So this is one way we can do it. Now suppose I want to so next thing we want to look at here is that we want to search for a value. No?
Once just small spelling mistake there for search.
Yeah, yes, sorry.
No problem.
So what we can do is that we want to we have a vector here. So we have a value say 3, and we want to check if the value 3 is there in the vector A. So for that, what we can do is we can do a boolean stores true and false. So if it's present, it will give true. If it's not present, it will give false. So this way we can use this function called binary search. This is again an algorithm which is defined here, which is inbuilt and is defined in this, and we can use this. So what we do is we look from the beginning to the end. If you want to look, if we want to look till a certain place in the vector, we can also do that. We instead of end, we can put something like 5, 6, 7. I don't know. We can also do that. What we do is we put A dot end, and then we put the value, say 3. And what do we get? We get false. So the value 3 is not present in the vector A, so we get false. So this is one way of checking. And similarly, if we do this, so definitely we'll get true. So I hope this is it's quite easy. I think everything's clear. So now the next thing we want to look at, the next functionality we want to look at for vectors is that how we can print all the values in a vector, how we can iterate through the values in a vector, how we can find out all the values, and then if we want to search for a particular value. So how can we do that? Let's do that. So for that, we are going to use something called an iterator. So what we have is we have this type called iterator in vector, and we can name it IT. So IT is a vector iterator of vector of TypeEnd. And what we can do is that we can try to find out. We can use this iterator to iterate through all the values in a vector. And if we want to search for a value, we'll just check if it's available or not.
Okay, this is nice. I like this stuff.
So any questions from your side till now?
Yeah, sorry.
So any questions you have till now? Anything more I should focus on? Okay, so
Sorry, Suhan, lost you there.
Okay, so we'll move ahead. So we have this iterator, suppose. We have this iterator, say IT2. So what we want to do is we want to print all the values in the vector. So let's do that. You can just, initialize with, just like a for loop. We are already. I hope everyone already knows the concept of for loop here. So we define a value at the beginning, and then we have a condition, and we keep iterating throughout the vector till we hit the condition that the vector is ended, and from that we want to print all the values that is present in the vector. So let's do that. So we start from a.begin. We will go till it2 not equals to the end. And we can, iterate. And if we want to print out all the values in the vector, we can just do cout. One thing I'd like to also point here that this iterator is basically a pointer. So it does not hold it does not hold the values of the vector, but it points to the values in the vector, the addresses inside the vector. So what we do is this value id of 2. So I'm sorry about this. Sorry. Yeah, so it should be a.begin. So what happens is that this iterator initially points at the beginning of the vector, and then it moves till the end, and it just prints out all the values that it points at. So I hope it's quite easy to understand. So this is what basically happens. We can just separate the values, and we can print them in separate lines. So this is how we can print the values, in a vector. So now there are many more you can say efficient or easier way in which we can also do this. So I would also like to mention some of those here. So you see this C++ STL is a quite efficient and quite intelligent library. So what happens here is that if we do not mention that, so here we have initialize the vector of type A. So what happens is that even if we don't mention it, we can also go ahead, like this. We want to go through all the values in the vector, and we can just do this, and it will give us the values in the vector. So this is one thing you can do. We can do, since the value x holds value in numerical values, integer value, we can also do these kind of things, like we can do x minus minus, we can do x plus plus and all that. We can do all of that. So I hope I hope everything is clear with vectors here. So it's very easy to use vectors. We can use them quite efficiently. We can sort them. We can also look at various ways in using operators, plus minus, increment, decrement. We can do all of those stuffs. So it's very easy to use. I hope it was very useful. So the next we want to move on to the next container here. So the next container we want to look here is, so this is vector. So let's say we want to look at sets. So let's define something like, now what are sets? Sets are also containers similar to vectors, but the functionality of sets here is that sets always keeps values in sorted way. Like in vectors, what we had was we had to put the values and then we had to sort them, but we do not need to do that in sets, because sets always keeps the values in the sorted order. So what happens is that, suppose, all right. So first
also it would also, I guess, take the mathematical properties of a set that we have studied, right? If I'm not wrong. Correct me if I'm wrong, sir.
This set is very similar to the set we use in Python. I think
Acha.
many of it's very similar because you can just keep unique values and we can also keep them in sorted ways. So are you getting me? Like it's very similar to that. Set. It's like a set. Like I have a set. It's not done. So it's not nothing to think on mathematically. Like I have a set. What does my set contains? My set contains a sorted way, sorted order of the unique values. We have a collection. We want to keep the unique values in the collection, and we want to keep in a sorted way. That's all. That's it. I hope it's very easy. It's very easy to use. It's very easy to understand. So let's see how to code them. So we can define a set S like this. So the set will contain integer values, and what we can do is we can insert values like this. We can use insert, say 10 s dot insert, and what happens is that every time we are inserting new values, the set is internally sorting them. So what's happening here is that at every step there is a sorting sorting process which happens. So whenever it's storing the values, it is not storing them at the back like the vector does. Instead, it sorts them and keeps them in stores them in the correct place. So let's look. We want to add more values like say s dot insert 100. We want to store s dot insert -100. So we can do all these things, and what happens is it keeps them all in a very sorted fashion. And by sorting, I obviously mean increasing order. We can also store them in a reverse order. So I'll also show that how to do that. So let's see what we can do here. So I hope this is clear. So set, we have first included the, you have to do this. So the header and all everything. So set is available, and we can set sets like this. And then suppose we want to, now we all know that we do not have any say duplicate values in it in the set. So we have unique values and we want to print them. So let's look at that. We want to print all values in the set. So we can do it like this. Int of x belongs to the set. And we can just print them out using this x. So what is that it does is quite easy. So it prints out all the values in the sets, and it just puts a space between them. So it's and at the end we can just go to a new line. So that's about it. So it's very easy to use sets and everything. So now I want to find out like whether a value is present in a set or not. Right? We have a set. We want to find out whether a value is present in a set or not. So how can we do that? So let's do that. Say auto. So what auto does is that auto just uses the correct data type, or you can say the correct like whatever this is. If it's if it's a value, it will just take int, and if it's say iterator, it will take it just takes the right type of container from the values it is holding. So that's auto. So what auto does is here that s dot find. So what happens is that auto finds that this function returns a boolean value. So it is a boolean variable. That's everything that auto does. Yeah. So we can just we want to find -1, and obviously -1 is not there in s, so we get false. Now we want to look at how we can print out all the values. So we have already looked at that, and one more thing I would also like to mention here is that if the value is present, suppose if we put 100, what it gives it gives us the correct way. So 100 is present, we know that. But suppose 100 was not present. Suppose it was 300. 300 was, we want to find whether it contains 300. So what will it return? So what it returns is that it returns the end position, because the iterator, it just goes through the set and it tries to find out 300, but it cannot. So what it gives is it gives s dot end. It gives the ending position of the set because it has not been able to find out. It has traveled in the very end. It has not been able to find out. So if we want to check if a value is there present in a set, so what we can do is we can use a if we can use a we can say a condition like so if it is equals to s dot end, so it means that the value is not there. So what happens is that we can just write out and then we will just give the value that it points at. So what is it going to give? It is going to give us the last value in the set because it has gone till the end. So what this does is that it is now pointing to the end of the set, the end position of the set, and the value of the end position of the set. This is printed out. So this is what this thing does. So I think everything is clear. So it is a pointer here. It does not hold any values. It is a pointer, and this pointer points to the correct position of whichever value we want to deal with. So that's about set. So I think it's very clear now. Set. We all know what is set and how we can work with set. I think because it's very easy. Sets are very powerful because we can store values in the correct order and we can use them accordingly. So I think that's a very important feature to have. So that's I hope that's all about set, and the remaining functionalities, there are the same functions that already exist. You can check them out in the C++ documentation or any STL documentation. There are lots of functions for vectors that we can use, and most of those functions also exists for sets. We can find out positions, we can find out if it's present or not, we can find out, we can slice them, we can cut them, we can add them. So all of these are same for sets. So let's look at the next container. So next container we want to look at are maps. So what is a map? So what is a map? Basically, map is something that maps or it associates say something like an integer with another integer or a character with another integer or a character with another character accordingly. So this is how we use a map. Map is a container which takes associates or bundles up like associates two values together. Suppose in this map variable we can associate two integer values with each other. So what happens is that we can write something like this. Say say what we want to associate a value like a of say 1 with 100, and suppose we want to associate this is very similar to dictionary in Python because we can this is very much like a key value pair, like there is a key, there is a value, we can associate them to and we can work with them as we want. So we can think of it like points in a Cartesian plane or something like that. We can associate or bundle it any way possible. So this is what we do using a map. Now let's look at another example. We can also have maps like
one question I have here. So the data types can be different. I can see that.
yeah,
I guess. Okay.
Yeah. So
and yeah, so I don't know, like it is like okay, I got it. I was thinking it is a bit similar to dictionary, but no. I mean, when you mentioned key value pair,
no, it is similar to dictionary, I believe, because we are mapping to some things.
Okay, fine. Like this is also good.
And like I always say that you also need to include the the map header file. So I'm not going to do that. Like I hope it's but when you use them, you have to include them. That's like I'm not going to like further come up here and include them for everything. But in your real work, you have to do them, or otherwise you'll get errors. So you cannot use them. So you have to include every type of container that you are using in your program. I hope it's very clear. So let's continue with maps. So we have this map that associates characters with integer values. And suppose a small example is that I have my name. So suppose I am a string which has characters. String x equals to, let's say something, anything, and so on. All right. So what we can do here is that, we want to count the chars. We want to count characters. So what we can do here is we can count how many times s or a belongs to the string. So for this we can use the map. So let's see how we can do that. Like for so what is this? What does this mean? So what this means is that for a character C, so C holds a character value at a time, and we want to iterate through all the the characters in the string X, and I want to count them. So what we can do is that this map called count. So what it holds is, so for every character value it holds, it just increases the values. So what happening here is that for every character value in C, I mean a character C in X, so it is for whatever character we find. Suppose at the first step we find S, if this is S, so suppose this is 0 initially, so this becomes 1. And if we go to the next character U, so this is U, and this becomes 1. So similarly, for every character it just increments the the integer value associated with it. So that's how we count. So in this case, for any kind of key value kind of associations, this is very important and is very useful. And now let's find out how we can print values, how we can go iterate through the values, and how we can find out from a key value pair and how we can print them. So suppose I want to count, or I want to print this, suppose A, and I want to print it. And I also want to and I will also want to print the count of Z. And obviously Z does not exist here, so it will be 0, and A is already there, so it will give us 100. I hope it is yes, sorry. Yes, so I think everything's clear here. We can just uh, find out the values associated with A. We can find out the values associated with the character wise, and we can just find out and everything. Now we can also delete keys. We can also erase keys. Suppose we have this A here. So if we want to delete it, we can just use A dot erase. So what it does is that it erases the key value pair, and if you want to insert a key value pair, we can use now. Suppose I want to find out a key value pair, say Z. So Z does not exist, so it will give us false. So this is a function we can use. We can also erase. We can also add. Just add and all that. You can just associate something like this, that C and P of this is where we can add it. Suppose this character 0, this character was not integer minded, so we can just associate it with like this 5, just anything we can do. So I hope everything's clear here. So these are various ways in which we can use maps. So I hope it's clear. If you want to know more, you can obviously find out more on the internet. But this is basically a very quick hands-on session that familiarizes everyone with how we can use them and how we can write programs with them, and this familiarizes with containers in STL. So another very important container that I want to mention also, very important. So let's look at pairs. So what are pairs? Pairs are very similar to map. Yes, very similar to map, you can say, but in this case, what pair is that pair stores two values associatedly. It's quite similar, but we can find out alternative ways of using them. Sure. So let's see what a pair is, and obviously, like I previously mentioned, you also need to include pair here. We also need to include anything. We want to include, suppose, any algorithm or anything, we have to include them. Otherwise, you cannot find them. Say, I have to include pair. So then we can use pairs. So let's use pair. So I can define a pair like this. So I have a pair like this. Say T equals to 2, 5. This is a pair. So there are two int values connected to each other as a pair. We can bundle it, and how to access them? We can just access them like this. Say it's a p. So p dot first. What is p dot first? So we can store it. We can store p dot first in an integer a like this. So what this gives us is it gives us 2, and if we want to store int b equals to b dot second, and we get 5. So these are various ways in which we can access the values in a pair. So we can use them first and second if we want to, like, say, print out values. So let's print the values in a pair. P dot and then I don't know why this is coming up. Sorry. So this is how we can print the values in a pair. So first we print p dot first, and we can print p dot second, and then we can all the pairwise values whatever we have, we can print them out one by one. Now another thing I would also like to mention here is that we can also have pairs of pairs. We can have pairs of pairs of pairs. We can have anything, nested pairs. We can have. So let's look at a nested pair. We can also have, say, int comma, see, another pair, pair of pair. We can have that. So this is a nested pair, if you can call it. So this, let's call it p. So what p has a pair in itself, and it has an integer value along with the pair. So we can initialize a starting value, say 1 comma. This is the nested pair I was talking about, p comma 4. So we can also have this. We can also have pair of pair of pair. So I hope you get the point. Now, if we want to find out for any nested pairs, so how can we find out the values? So if we want to find out which is the first value in a nested pair, so what we can do is we can just if you want to print, so we can print it like this. Say p dot first. This gives 1 obviously, and if we want to find out the next value, we can get p dot first, sorry, p dot second, dot first. What does this give? Obviously this gives 3, as we have here. This is the first value in the second pair. So this is how we can access the values in a pair of pairs and so on. So I hope this is very easy to use. And what another thing I would also like to show, that we can also have array of pairs. So pairs are like a containers, but since we can have nested pairs, we can also have an array of pairs, like an array of structures or something like that. As we all know. So let's see how we can have a array of pairs. So say this is my data type, data type, if you can call it. So we have this int pair, and then we have an array of type int pair, and we can initialize the array like this. Say like this array will have, let's say it has 2 pairs, 1, 3 and 7, 8, 7, 9. So this is an example of an array of pairs. So we can have many types of things like this. And suppose we just want to print out this value 9. So what can we do? Yeah. So what can we do? We can just, since this pair is the second value in this array, so we can just do ARR of 1 dot second. What this gives us is this will give us the value 9. I believe. See, this is the the pair at position 1, and this is the second value in the pair array 1 dot second. So this gives us 9. So that's all of pairs. So we have so far we have looked about, I believe we have seen maps, we have seen pairs, we have seen sets, we have seen vectors. We want to look at a few smaller other examples. So let's have a look at them. Now the next thing I want to discuss here is a multi-set. Now, what is a multi-set? Say a multi-set is very similar to a set, like we already discussed. So void multi-set. It's another very important container that we can use in STL. So these are various type of containers that I'm discussing, because these containers are the basis from which various libraries like NumPy or pandas and various things. This is how it works in the backend. Like using these STL containers, we can build up complex classes, we can build up complex functions, we can build up complex containers and all that stuff. So this is very important. This foundation is very important to have if we want to work with bigger libraries or bigger classes that are using C++ in the backend. So for now, let's look at multiset. So the thing on multiset is that everything is same as set. We have all the functions that are there in set. Like we can find out, like we saw sets here. So we can insert values in a multi-set, we can print them. Everything is just same as what we have done here. But there are some added functionalities in multi-set. So let's look at the functionalities. So what the functionality we have here is that in a multi-set, that duplicate elements can be there. So duplicate elements we can have. So this is all about multi-sets, that everything is same and we can just have duplicate elements. So let's see an example. Suppose multi-set, we can just initialize it like this: multi-set of int, say ms. So this is a multi-set, and we can just use find various. We can insert one. We can insert one again. We can duplicate ones we can insert, and they will stay. They will not be ignored, because a multi-set can store duplicate values in a sorted way. So that's all about multi-set. And all, of course, we also have the same functions, and as in set, say erase. We have functions like, say find. We have erase, all that stuff. So the same as sets. That's all. So the next container, like this will be the the last container that I want to discuss, or if not the last, like one of the last things I want to discuss today. So this is also something very similar to set. This is called an unordered set. So what is an unordered set? Unordered set is basically a set that you can use as a vector. Are you getting me? Like in a set, so like I already discussed that the value is stored in a sorted way, but in an unordered set, that we can store them as we want. And there are some functions like lower bound, upper bound, all these things that we can define lower bounds and we can define upper bounds and we can search from them. So these things are not present in unordered set because they're unordered, right? So basically, these functions will not work because they are stored in a very random manner. So that's about it. So there is no order or anything. We can just write it like this: unordered set. You can just we can have unordered set, say like something like this, like this is not exactly an initialization statement. I'm just showing in the example. We can have 5, we can have 4, we can have 5 again. So this is how the unordered set just stores the values, and this is how it works. So that's about it for containers. So I've discussed quite a few containers, important, and I hope everything's clear to everyone. So I have today. So we have discussed, I believe, we have discussed vectors, we have discussed set, we have discussed map, we have discussed pairs, multi-set, unordered set, and there are quite a few more containers that there are also, they can be derived from, multi-sets, they can be derived from set, they can be derived from vectors. So they can all be derived from these following things. So we can just go and see them through the internet and all that. So that's all, I believe, from my side. That's all I can.
Okay, that was amazing. Like this
quite
is
important. Yeah.
so. Yeah, anything you wanted to add, Suhan, in case?
Yeah, like you can have, like I already mentioned about derived containers in STL, like stacks, queues. We can also have these, but these are all derived, and we can actually use them similar to how we have used, like in set
Okay.
or multi-set, but they can be derived and they are very easy to use, very similar to sets and all that. So I hope this gives a very familiar, like it familiarizes everyone with the concept of STL and containers. Yeah, that's it.
Okay. So Suhan.
Hmm.
So yeah, this is how will this knowledge help? Like
This
let's say.
knowledge will help a lot because if people want to start with C++ development, or they can, if they want to write production softwares using C++, and they want to use libraries like, say, tensor libraries like Eigen, or they want to use Boost libraries, they want to use a library like the OpenCV and all that. So what happens is that, so this STL forms the the core of the backend computation that goes on in C++.
Okay.
See, the C++ STL is the thing from where all these complex containers can be derived, right? So
Okay.
all these tensor, X tensor, and there are lots of libraries which are used for high-end computation at the backend. So all of these can be derived from STL. So if one is familiar with STL, they can write and
Yeah.
develop software on the backend stuff and all that.
Yeah, this was really like a good introduction to STL. Like it is a vast
Yeah, it's a
concept.
very vast library, like I already mentioned. It's not possible to like just show
Yeah,
everything.
like so there is like I think something called ETL which uses STL, like embedded template library.
Yeah,
I
definitely.
saw.
Like because this is the basically the the foundation blocks. You can say the building blocks of all the various optimized or say high end computation, high end containers that are available in the various libraries that this is built in, right? So you can use them as you want in your development projects and all that.
That's good. Maybe like we can explore someday the ETL and TensorFlow, PyTorch
Yeah, definitely.
on
Yeah.
an STL perspective, so people will get to know how these were created. Like we are just blindly just using the functions in Python. They are Pythonic, like the so everything is easier. So we don't know exactly what happens in the backend.
Yes, definitely.
So
C++ is one of, like I already mentioned, that we can work with, this the C and C++ language enables us to work at a very low level hardware level of our systems. So
exactly,
but
exactly.
it gives us very high computation power. It gives us very accurate, just very efficient speed and all that. So this enhances our experience of building production level software.
Yes. One more thing, like I just personally wanted to add, like this is my personal experience and personal feedback that I have, received from some people. So in the embedded computing world, like I use Jetson Nano for some side projects. So like there is this SDK called DeepStream, which you use for live inference and AI-based deployments on embedded Jetson platform, NVIDIA Jetson platform. Okay, so just recently they added the Python binding support, and previously, like you could develop your DeepStream apps on Jetson using C++. All right. So yeah, like by default, we know that in the embedded world, C++ is like the favored computing language, right? Like, am I wrong
Yeah,
here,
yeah,
Suhan?
definitely. Yeah, definitely.
Hello?
Yeah, yeah, definitely.
Yeah, so like there was a comparison of performance, like DeepStream C++ app on Jetson Nano versus DeepStream Python app on Jetson Nano. Okay, so when the live inference on camera was executed, what happened was, like, this is a personal feedback from someone I know from the NVIDIA developer network, actually, like a known acquaintance. So what he said, that there is a difference of 10 frames per second. In C++, it was rather much faster. So what's your take on this? Like, what's your reaction here?
So see, if so the we when we are using C++, so basically what happens is that all these say the because basically what I have seen here is that most of the Python applications, what they have is that when they want to use the computing resources, or when they want to match the speed or anything, they have to be compiled. They have to be converted to a C++ file, or say like a JIT file or anything. They have to be to a another kind of script. They have to be there has to be a script that has to be derived. So maybe that takes some time, and in C++, when we are using C++,
Exactly.
we can directly just we can directly
To
deploy
reduce the, I mean,
yeah, we want to deploy the thing, right? So C++
yes,
is the best in terms of deployment.
like
So there must be some kind of script
he,
what going on.
yeah. Yeah. I mean, perhaps one of the best, most favored computing languages out there.
Yes, definitely.
That was a good, like, this was an interesting session, Swan. Also a very interesting session, Abhigyan. I mean, both of you really like enlightened the audience with the most recent and latest concepts revolving around C++. So like I hope like the audience will also use it as a reference video when
Yeah,
they
definitely.
like
Like
ship to
this session
production.
was actually meant to like familiarize everyone with C++, how they can use STL in their personal projects and all that, so they can get started.
Yeah, I think maybe we should have one more session on this, like from a deep, industrial perspective, something like that. Maybe we should plan.
Yes, definitely we
Like,
should.
what's this one? Yeah.
Yeah, definitely we can have, like, we can
Okay.
pursue some advanced concepts, like how we can some computing containers like that. Suppose we can look at the backend stuff of the various libraries like NumPy or Pandas, how they can be they are getting deployed,
That
because
will
we
be,
know that it's a fact, right? NumPy runs on
yeah.
C++ containers, everyone
There
knows
are
that.
people also who, yeah, there are also like people who want to get their hands dirty on the code. They want to develop from scratch, right? Just for fun.
Yes,
And for them, it will be a
yeah, it will be a very
uh,
interesting session for their perspective, because these kind of things are like I've seen, like not much discussed nowadays, right? So If we want to get our hands dirty, then C++ is the best way to go.
Okay, so I guess like we should wrap up the session then. Like with we have time for some Q&A. We'll take some
Yeah,
questions.
definitely, yes.
We'll definitely take some questions. So, guys, whoever are watching the the live stream, just drop your queries in the live chat. So we'll just browse the chat windows, chat window, whatever we have seen. Okay, some people, okay, in the beginning, I guess were facing some problems. I guess there were some internet issues, but I guess it was resolved within 2 or 3 minutes. I guess it was fine. Okay, okay, one person has said that who is speaking couldn't understand. I guess it was an issue from Abhigyan's end. Okay, no problem. So apart from that, any live questions we have, guys? Okay, nice from Abhishek Prusti. Okay, thank you. Thank you for your feedback. Okay, Abhigyan sir, you're a big fan. So Abhigyan, you have a fan following, man. That's nice.
That's just my friend. He was strolling around.
uh, that's great. So guys, like Abhigyan, like he has like the one he mentioned what regarding a GitHub URL, right? So we have dropped the necessary reference URL in the chat window. Do go through that. And Akama, okay, you have sent an emoji, smiling emoji. Thank you. What we'll do is we'll also reply with a smiling emoji. Thanks. Dedicated to Akama. Amlan Kumar Ashchari, actually. So that's his gaming name. He's one of our members of NUA. So I guess we do not have any questions yet. So Abhigyan, do you have any questions for Suhan from your end?
Not any that I can think of right now.
And Suhan to Abhigyan.
No, man, not really.
Okay.
No, just let's wait.
Okay, I guess.
Questions coming up.
Yeah, we'll wait. We'll just have some normal conversation. We'll wait for 2 or 3 minutes. Um, so like one more question like I had from my side. So in the embedded computing platform, what are the devices like you guys have used?
Me personally, I've used Arduinos and Pixhawk board, if you know that.
Acha, okay, yeah, I have heard about that, though I have not seen it in my own eyes.
Yeah,
Like, how is
it's
it like?
basically mostly a drone controller. It yeah, has some cool into it, but it's a very complex backend, to be honest.
Acha, yeah, maybe like both AMD and Nvidia are deeply focusing in that vertical right now. They are working with partners, and in fact, they are also releasing their own OEM boards. The Jetson, which and their software library is damn good, man. Maybe you should definitely check that out. And Suhan, what about you?
Like same as Abhigyan, I also used a few applications on Arduino, like in my first year days. I was very interested in robotics and all that. But then I thought that you can use embedded softwares like embedded C and all that, because there are lots of microcontrollers available that we can it's actually this Arduino thing is actually very similar to something like we are just getting the same like level as like it's a very
Okay.
abstract. This high level abstraction in Arduino. That's what I feel. So what Arduino does not allow us in the same way to get very close to the hardware of the microcontrollers and all that. Because if you have seen one or two codes in Arduino, if you have seen if you have programmed in Arduino, like it's very high level and all that. So it doesn't allow penetration into the hardware. This is one thing I've seen. So we
Okay.
can use other microcontrollers. Like I don't quite remember like what is the processor that's used. I have to check on Google. But there are lots of other microprocessors available that we can program using C++. They can also be programmed using C++. And then we can use various components like clock, like clocks and all that, drivers. And then we can develop robotic applications if we want.
Okay. Okay, I think we have a comment from Aditya Gupta. He's saying Yamlan. I think he's referring to me. Just trying to being sarcastic. We can just ignore that. Aditya, if you have any question, you can definitely ask us. I mean, we are dying for questions right now. So, Suhan, like, there is another embedded device to look into. I guess OpenCV just came up with. I don't remember. Have you seen it actually? So it's a very tiny system on chip. It comes with a 4K stereo cam included, and it has, I think, Intel Myriad chip, I guess. That is also something interesting to look into.
If I might
Like,
interject here,
Yeah, Abhigyan.
as for the OpenCV board, I want to add that I just read about that OpenCV board just like about an hour before this uh, webinar. So I was like just reading to it. So I'm like, what's good about OpenCV C++ library, at least as far as I've used it, is that their
Yeah,
backend of
yes.
the inference engine is very good on CPUs.
Yeah, because yeah,
Their
on
inference engine was like intent at first it was just intended for CPUs. They just introduced GPUs, I think barely 12 months ago. So their CPU version has matured a lot. So it runs on smaller chips much better than you'd expect.
that's like I am also getting to know this from you, but still like yet to see like I want to explore myself. How is the performance? Okay, so Aditya here says that I just joined now. No problem. Any questions you want to throw away, not related to C++ or related to anime or something, also you can ask. No issues. I mean, I guess Suhan and Abhigyan like are into anime stuff, if I'm not wrong.
I don't watch anime.
You don't watch anime. Okay, fine. Um,
I watch
there are some.
anime, but yeah,
You
but
watch.
then like just occasionally just one or two animes I watch.
Yeah, there are some anime. There are some animes based on coding also. I mean, the Japanese guys have literally gone to the next level. I mean, almost on everything you will find an anime. Uh,
No, these animes have like reached every corner of the universe, haven't they? They have like reached every.
yeah.
They have just gone beyond the universe. It seems they are going to other universes and all that stuff, haven't they?
Okay, Aditya has a question here. Have you guys tried Rust? Any one of you has tried Rust? The language by Microsoft for faster computing, especially for HPC. Abhigyan or
Not
Swan?
me personally. I've heard
So
about it, but I've never used it
yes,
personally.
Rust. I have also heard a lot like lately, but I have not like seen any like big applications or very. I have heard that it is very similar to C. That I have heard that it is very similar to C++, and I am not sure. Like I have not used Rust definitely, but it maybe
I
the
guess like Microsoft.
market has catching up to do in that terms.
I
Rust
guess
might be a good alternative, I must say, because it has a few
okay. Okay,
interesting.
sorry. Sorry, it's a language by Mozilla. I said Microsoft. Sorry, it's a language by Mozilla. Okay, maybe something interesting to look into.
Yeah, definitely.
Thank
Yeah,
you for letting us know. Another computing language that's interesting to look into, like what I have seen, is Julia. It is actually gaining a strong popularity and community outreach. who knows, it might outsmart C++ someday. Like you never know. And in fact, with some companies, they have made partnerships. Because there are many semiconductor companies, right? And they want a good computing language. So Julia is also like serving that purpose.
Julia is often like I have seen, like I have heard a lot that it is like touted to be
In
the
fact,
next.
yeah, in fact, Suhan, if you remember, you were there in our NUA Dev meetup,
Yeah, yeah,
Kolkata,
right. Yeah, I was there.
when there was no corona and we had a good gathering of people, no social distancing, nothing. We actually enjoyed that event back then. There was no pandemic, no lockdown. I miss that day. So we had a speaker, right? He's from
Mihal.
yeah, yes. So he was a former CTO of Just Dial. So he quoted while in the Gizmo Quest lab inauguration, computing lab inauguration. He said that to one of our speakers and co-hosts that Abhimanyu Bandyopadhyay that have a look into Julia. Have a look into Julia for computing. He mentioned that. So if he's mentioning that, so I guess most of the people are right now favoring Julia and want to shift into that perspective, you know, deploying Julia in a production-based environment.
I'm not quite sure about production actually, but what I am quite sure about, like I've like spent a lot of time, finding out or
But
listening
see,
out.
I'll tell you one thing. Julia is one of the partners of NVIDIA Inception. Okay, do you know about NVIDIA Inception?
No.
So NVIDIA Inception is basically they have this ecosystem for startups. They help startups to grow and they provide knowledge about how to leverage their GPUs in their industrial use case, and they also help marketing them. So Julia is right now an NVIDIA Inception member. That means things are quite serious now. I can pretty much bet. Maybe like what I am thinking, we should ask around someone like if we could have a session on Julia separately. Like what are your thoughts, Abhigyan and Swan?
Yes, definitely.
Yeah, we could do that. I had a question. Is Julia strongly tied? I had a question. Is Julia strongly tied?
Like I don't know. I don't have that much thorough knowledge regarding Julia.
Okay.
But
Julia,
yeah, I would say
yeah,
that
library for machine learning. I know that. It has,
syntactically, yes, one, please continue.
like it has a lot of libraries, like many like machine learning developers are favoring Julia for like they are just discarding
Yes,
Python, and what they want to see Julia as a replacement for Python because it has a lot of libraries for inbuilt libraries, and it has
yes,
community backing. But I am not sure about whether it
yeah,
can.
yes. So syntactically, it is very simpler. You can say like not as similar to Python, but maybe like better than C++ in terms of convenience. Again, I hope that answers your question.
Yeah, that does.
Yeah.
But what I also feel
So
is
shall
that
we?
like Julia is something that definitely we can look into the future. But C++ is something that's here to stay, right? See, these C++ has been there for a lot of time, and it has a lot of like a very like huge base of softwares which use C++, and I don't really think that Julia can really come as a real replacement for C++ because C++ has a huge history, right? It has a like it C++ is it is one of the language is one of the say the building blocks of like humanity of mankind, you can say, because all of the technology, all of the all of this infrastructure that has been built on these two languages, C and C++, it's huge, right? So it's going to I believe it's going to take a lot more
Yeah, yeah. I agree with you. I'm actually trying to present that my screen because I wanted to show something.
Yes, I can see you're presenting.
Like, is it visible?
No.
Okay. Okay. You can see, right? Yeah. So I just found this embedded template library, like a C++ template library for embedded application. It is MIT licensed. So I don't know anything regarding this actually. I have no clue. So I was just checking, like they have their containers, they have
I can't see anything, by the way.
their own.
It's still not visible.
I was like, this is. Yeah, sorry about that, guys. Am I audible?
Yeah.
Hello.
Yeah, you're audible. Please carry on.
Okay, I was just like I just checked. Yeah, I just checked the that ETL library actually. I was just checking and nothing was visible, I guess.
Yeah, we couldn't see anything.
Okay. Anyways, like I guess maybe like we should wrap up by now. So like I would strongly recommend everyone to also take a look into embedded template library. It is something that is an extended version of STL. So it's MIT licensed.
Everyone, if you want.
Maybe we should have a yes.
Please share the link with everyone so that they can check it out themselves.
Yeah, actually, you have to. Can someone send it to Saurav here? I have dropped in the chat window actually some link actually. No problem. So we will mention it at the description of the video. Like that won't be a problem for future reference. So anything else you guys want to add? I guess it's already 2 hours we have taken for the session.
Nothing on my part to add.
I guess I'm like, given everything.
Okay, Suhan, I couldn't catch you there. You said.
Hello, can you hear me now?
Yeah.
So like I believe I have like said everything I wanted to say. So
Okay. Okay. Fine then. So thanks a lot, guys, for providing so much knowledge on C++ today. Let's have more sessions in the future.
yeah,
So
definitely, sure.
we'll definitely, and it was really fun. So to the people whoever are watching, thank you for joining us, and sorry for the inconvenience if anything happened. The quality of the stream. We'll try to become better. We'll definitely become better in the next session. So thank you guys. Thank you all.
Thank you, everyone.
Yeah.
Yeah, thank
Okay.
you.
Okay. Bye.